Welcome everyone to today's webinar. My name is Jay Shu. I'm the product sales manager in Advantech within the Embedded Core Group. For today's webinar, we have invited Sylvain Ekel from Microsoft. Sylvain has more than 15 years of experience in the Windows Embedded and Internet of Things and has joined Microsoft in 2004. As an account technology strategy manager, Sylvain leads the Microsoft OEM engineering and services for Windows Embedded in EMEA. Today we also have Nicholas Lutmer in the audience who can help with some Q&As. He is the channel executive of Microsoft. Today Sylvain will focus on giving you an overview of the latest Windows Embedded products, but before that I would like to take a few minutes on the topic end of support of XP Pro. XP Pro is a default OS which is being tested for compatibility with all Advantech standard models. So naturally, when it was announced that it's going end of support, we got many questions about this topic. So the end of support was April 8th, 2014. And first of all, XP Pro will remain orderable on Advantech platforms till the end of supply date, which is December 31st, 2016. So for existing projects where you cannot migrate yet to modern OS, if you cannot switch immediately, there's also a middle solution that we can support you with. So first of all, the main impact of end of support is there's no more hotfix and security patches coming from Microsoft anymore. And for this, we have two kinds of alternatives if you want to stay with the same OS that you have used for so many years. So first of all, you can leverage Advantech resources with sync-up workaround solutions that we have adopted before, and so if you have the same issues, then we can use the same solutions. Another way is using SUSE Access, which we provide with all Advantech embedded platforms. To this, we have McAfee application control. So you can use the whitelist function on McAfee to use as a system protect kind of solution. So for projects, new projects where, or not new projects, but with projects which are XP-based AP, you can also decide to switch to XP Embedded or Windows Embedded Standard 2009. There you can see that the technical support as well as the supply support is slightly longer than the XP Pro. So these could be middle-way solutions before you migrate to a modern OS. So for new projects, I would like to give the mic to Sylvain, who will focus on the Windows Embedded portfolio. And at the end of his slides, there will be a Q&A session. So you can raise your questions by then. So Sylvain, I give you the mic.
Thank you very much. So just want to go back to my presentation here. Thank you very much, Jay. And good morning, everyone. Happy to be here. Today, as Jay mentioned, we'll talk mainly about Windows Embedded 8.1 industry and the latest product, and giving you a little bit of an overview of the technology direction we're having in the embedded space and the Internet of Things space on the Windows code base. There's a lot of things that we could talk about from Microsoft Windows Embedded. In half an hour, this is kind of two topics I wanted to talk about. Windows Embedded 8.1, and first of all, some additional information about the Windows XP end of support, as this is a very talked about topic in the press and with OEMs and device manufacturers all over the world. So Windows XP has reached the end of the support lifecycle after 13 years of support on April 8, 2014. This is basically even an extended timeline because our operating system from business side, all products from Microsoft on the business sides are supported 10 years. 5 years of mainstream support with free access to hotfixes, QFCs, and patch, and 5 years of extended support after that, which is the security fix and the critical fixes only are free. The rest are available through an extended support agreement. As we go into the end of support lifecycle, there's different options. Of course, you can use as almost say stopgap measures to transition to a more modern operating system. Some of them are the one that Che mentioned. Another one is to have a custom support agreement with Microsoft that is a 2 to 3 years, 1 to 3 years contract to help you keep your platform supported for a few years with a migration path to a modern operating system. If you need more information about this, your Microsoft account representative can definitively help you, and or you can try to find hold of me. I'd be happy to help you with that. That said, there is a lot of risk on staying on XP, right? It's not only the end of the security updates, it's also compliance issues. It's the maintenance cost of the platform that's going to raise very rapidly, but also lack of support for a new chipset. You know, if you want to do a Bay-Trail based platform with Intel, well, XP will not be supported. If you want to use new communication technique, and we'll go into that, XP will not support that. There is also a lot of very positive reasons to move to a modern platform. It's not only about the application side, where you get new APIs. It's not only about the driver side, where you get access to, of course, the latest drivers from our silicon vendor and our independent hardware vendors, but also new technology. It's also longer life cycle from a commercial side, from a technical side, and ensuring a continuity and mitigating or eliminating business and technology risk to stay on the older platform. So today, I just wanted to give some example on what I'm talking about here today. Just go one slide more. Oops. Sorry for that. So in security, for example, if you look at what Windows 8 offers today on security that is not on Windows XP, you have things like App Locker, and we'll go a little bit in detail what it is. You have BitLocker encryption systems for your hard drive, for your files, but also BitLocker to go to encrypt USB drive, and additional security functions such as trusted boot, UEFI support to boot faster, of course, but also to have a completely secure boot process. There is nothing on XP which was designed 13 years ago to be able to really have a complete from the time the motherboard is powered to the complete life of the application, a complete security measure. We have that on Windows 8. Device encryption, Windows Defender, included anti-malware solution, assign access to Logon an application to a particular user. All those features and many others are including to Windows 8. So it's not only about patching potential security holes, it's also about adopting a much more proactive approach to security and in general reliability of the device. But it's not only about security. You have different advantages. I talked about hardware. They will be discontinuing drivers and silicon support as we go, as we move forward. So I just wanted to mention some of the technology that Windows 8 actually provides compared to XP. So one of them is USB 3, right? Or the latest version of Bluetooth with 4.0, Wi-Fi Direct, Miracast, near field communication. All those are technologies that are built in Windows Embedded 8. And even if you don't use them today, who knows what you or your customer will be able to design in the future and will start requesting those technology, or they become more and more pervasive in the consumer space, of course, but the business space as well. So one of them is definitively in terms of being able to project into wireless displays or secondary displays. USB 3 is more and more demand for us as well in many markets where the ability to use higher bandwidth is becoming more and more important. On top of that, you got also a lot of additional features of the operating system, gesture, multi-touch, Kinect, things you've heard in the consumer space, and that's becoming more and more important in the embedded and device design space as well. So this is really the visible tip of the iceberg. Without going into a full list, which take a few days, of what we include in Windows Embedded 8, we also have a number of technology that people want to use today. We included 3D printing in Windows 8, for example, so direct support for 3D printing with new application coming on board and many embedded devices leveraging those technology. It's also about management, the support for latest Microsoft or third-party management technology in the enterprise, as well as PowerShell 4.0, an ability to better control how you manage your device and how you configure it. So those are just a few of the reasons why we are moving into more and more a modern operating system. Windows 7 is one option, Windows 8 is another option, and today we're going to focus mainly on the new technology around Windows Embedded 8.1 industry. Extending Windows to specialized device. This is really about explaining what is Windows Embedded. A lot of you know Windows and probably are using it today either at work or at home or for your specialized devices. What Windows Embedded is about is really proposing a product vision and also licensing vision for device manufacturer, people that build embedded and specialized devices, devices that are fixed function, devices that have a purpose, a clearly defined purpose in a vertical market. Or in other words, devices that are not a PC. And so you see a few examples on the slides, right? ATMs, MRI machine, industrial robots, controller, kiosk, consumer devices to some extent, everything that is a computer in the heart, but that the end user sees as a device. Change slide, please. So in details, what do we offer? We offer first a family of products for specialized devices. We have a number of operating system products. I will go into a comprehensive list in the next slide. And we also have something that's very important. Software is really about licensing, and licensing is adapted from the Windows Embedded side to the needs of device manufacturer. This means we allow customization of the operating system, we allow branding of the operating system, we allow lockdown of the operating system. We have a set of tools to be able to do this. And we also have different deployment mechanism or deployment rights to make sure that when a device manufacturer is building an embedded device or a specialized device with Windows Embedded, they'll be able to easily deploy his device with a customized operating system. And it's not only about the product, it's also about the ecosystem. It's also about our system integrators, or board manufacturer, or distributors that are specific to Windows Embedded. They're not the same distributors that you'll find in other channels in Microsoft. So they know the market, they know the problematic and the concerns of embedded device manufacturers or OEMs, embedded OEMs. a number of partners to help you with training, with consulting, with application and driver development, and all type of integration services for your device, but also for your end customers and end users, often enterprises. Enterprises that want to integrate a specialized device into their IT infrastructure. Next slide, please. So if you look at this huge list of the Windows Embedded current portfolio, it could be a little bit a lot of information at once. So I'm going to try to simplify a little bit this slide. We have first on the top left Windows Embedded Compact. Windows Embedded Compact is the successor of Windows CE. Windows CE that was built in 1996 as a low footprint um, with power management and support for ARM and x86 operating system. It really quickly morphed in 2000 as a real-time industrial quality operating system with Windows CE 3.0. And over the years, over the last 14 years, we released different versions, adding features. Recently with Windows Embedded Compact 2013, refactoring the complete compilers to be able to compile a Windows Embedded Compact operating system with the same compiler that you would use to build a ARM Windows application, making sure that we have a strong multi-core and multi-silicon architecture support. Windows Embedded Handheld is a specific version of this, usually built on top of Windows Mobile and no Windows Phone for handheld devices, vertical devices that share a lot of technology and user experience with our consumer side of the house building Windows phones. But for device manufacturer, they build ruggedized, fixed function, enterprise-ready devices. We announced a number of partnership and devices that will come on the market very soon with Windows Embedded Handheld 8. That's not the purpose of this presentation, but you can definitely find information on the web with that. Then we have Windows Embedded Standard, which is the next version or the successor of Windows XP Embedded. And the standard line of product is taking a major version of Windows, be it XP, or 7 or 8, and building a tool to help you create your own operating system image through the component of Windows. So we componentize Windows, we add specific embedded features, and we build a tool that allows you to create your own image based on Windows. Keep application driver compatibility, but you're able to control how your image looks like and behaves. The industry line of product, one we're going to talk about today mainly, is a version of Windows or Windows Standard for specific markets. I'm just going to talk about it later on, so I'm going to leave it at that for now. Windows Embedded Enterprise and Windows Embedded Servers are actually the same product that you'll find in many consumer PCs or off-the-shelf servers with specific licensing rights. So there's the same version of Windows, Windows XP, Windows Vista, 7, and Windows 8 and 8.1, or Windows Server 2012, 2008, and 2003, but with the embedded licensing that allows you to customize or deploy differently. In addition to Windows Embedded Servers, we also have one little exception to that portfolio of operating system. It's a server application. It's SQL Server. Again, for embedded rights, for embedded usage, for specialized usage, SQL Server is available through the Windows Embedded channel. Next slide, please. So, Industry 8.1. Windows Embedded 8.1 Industry is the embedded version of Windows 8.1. You may have seen it on the market. I hope you're running it on your PC as I do. A great operating system. Recently, we released another update to it, either um, uh, making it extremely much better to use with mouse and keyboards, reflecting a lot of the consumer scenarios that we're asked about. We have new rules for installing application. We introduced a number of features that we'll talk about briefly. But what's important here is that we do have a version of Windows Embedded 8, Windows 8.1 for specialized devices, and that's Windows Embedded 8.1 Industry. The next slide, please. Windows Embedded 8.1 Industry is actually the first operating system with embedded capabilities, that we call lockdown features, but which is entirely based on a full version of Windows 8.1. What does this mean? It means we took Windows 8.1, all the features that they have, of course, all the operating system, all the way it behaves, and we added specific lockdown and embedded capabilities to help you control and customize, brand, and secure Windows 8.1 for your device. The first advantages of doing that is, of course, full compatibility with application and drivers. So if you take an XP Embedded or Windows Embedded Standard version of our offerings, you have to include the right component in your image to make sure your application will run. With Windows Embedded 8.1, you got all those components as a base. But that's not the only advantage we have from doing that. A second advantage is a complete parity with the Windows roadmap, ensuring that we have a very quick release after Windows releases. So we are completely on par with what the Windows product group is doing. So when a new version of Windows comes, we don't have to wait 3 months or 6 months for the customization and componentization work to happen on our side, but really being able to provide an embedded version very quickly. Embedded capabilities similarly are developed in-house by our PG, by our product group, and are updatable separately. So we are able to deliver this operating system much quicker than in the past. We also leverage a lot of third-party support, right? If a security third-party vendor or a silicon vendor like Intel supports a major Windows, it automatically cascade into Windows Embedded by doing that. Integration enterprise is much easier as well. The deployment and servicing tool that anybody can use with Windows today, the deployment kit, System Center Manager, the Windows Service Update Server, all those tools will work the same way on a Windows Embedded 8.1 Industry device or Windows 8.1 devices. So this is really the reason why we moved the industry product line into that direction, which is actually a big change for anyone following our technology roadmap, the Windows Embedded technology roadmap in the last 5 or 6 years. Next slide, please. So how do you deploy and install a Windows Embedded 8.1 device? Here it's very much a high-level overview, trying to give you a little bit of the major steps happening in a device manufacturer. For the interest of time, I'm not going to go into a lot of details, but maybe you may have some questions at the end of the presentation. And again, I encourage you to ask questions. The first steps in building a device with Windows Embedded 8.1 is to create a master device. So actually installing the operating system on the device. This is done by a wizard, similarly that you will install any version of Windows. The second is to customize, add your application, do all the customization that needs to happen at runtime. You could test your driver, test your application, log down your device, installing your lockdown features, uh, just making basically a golden image that you will clone to multiple devices in the next two steps. You use sysprep to generalize, make sure you reset the SID, and all those steps are really can be made automatic through scripts or a configuration file. And you use the ADK, the Advanced Deployment Kit, that we build for Windows 8.1 exactly the same way for 8.1 industry. And you use that ADK to capture your image and deploy it, and mass deploy it to multiple devices, through network, through mass media, through USB storage, and manage also your activation, your online activation or offline activation. There's different ways of managing that process, either through a direct internet connection or USB keys or LAN, and that can be also done automatically. Next slide, please. So there's a few important tools. Again, not going too much into details, but I give you maybe, hopefully, some navigation map to know about those, either acronyms or tools. So I talked about the setup and installer for embedded industry. This is really the same one that you'll find in Windows 8 or 8.1. Actually, I got the wrong logo right here. Another important tool is the Embedded Lockdown Manager, or ELM. The Embedded Lockdown Manager is actually something quite new in Windows Embedded 8 line of product, and it is a MMC plugin to manage all the lockdown features on your devices. We recently, in February, early February, built a major updates to the ELM, fixed a few issues we had, but also added support for a lot more lockdown features. So I encourage you to check it out if you're using 8.1 industry today. Windows SIM, or System Image Manager, is the Windows tool to create a specific install of Windows 8.1. So I mentioned that you use the setup or installer to create your base image. You can also use Windows SIM to create a completely automatic installation of that base image and make sure that your settings are always the same if you don't want to go to the next by next install. So multiple options here to deploy. The ADK 8.1 is a free download, but also part of the OPK that you'll get from your distributor. And the ADK 8.1 is really a suite of tools. A suite of tools to create WinPE or pre-installation environment medias, CD network or USB storage, manage activation remotely with VAMT, and a lot of other tools to manage performance, to do application compatibility testing. So if you have an XP application, for example, and you're worried about how it's going to run on Windows 8, you can use that tool to actually analyze the application. And the tool will tell you if it finds any errors, being able to point you on some workarounds for some errors as well, and make sure that you manage the application migration in a good way, much better than trial errors. So a lot of tools here. Again, check it out. It's a free download if you wanna install it and look at the different tools that there is. There is actually quite a lot of tools. I believe it is almost a 4 gigs download for the whole tools. There's a web installer that helps you to manage that download. Next slide, please. So I mentioned embedded features. Embedded features that we know call lockdown features are a suite of additional features that we add on top of Windows Embedded 8.1 to create 8.1 industry. So I'm going to go into a list of those. I think I got almost all of them, at least the most important ones. And hopefully they'll give you some ideas about how you can build a specialized devices with 8.1 industry. Next slide, please. So the first one is App Launcher. So App Launcher is one of the features that enables you to have one application as a shell. It is important in a specialized devices that you may want to completely hide the desktop user interface or the start screen and ensuring that only one application runs. We could always do that in Windows Embedded Standard and XP Embedded and Windows Embedded 8 and today with 8.1 Industry with Shell Launcher that allows you to use a desktop application or Win32 application as a shell. We now have another features on top of that called App Launcher that allows you to use a modern app, a Windows 8 Store app, as a shell, as a primary user interface for your devices. If you want to do this, and if you looked at it in the past, there was some issues in doing that for inter-process communication with the desktop or loading of the application, installing of the application. We solved most of those issues with the latest update on 8.1 Industry. So listening to our device designer feedback. So I encourage you to have a look at it and be happy to answer questions later on. Next slide, please. The gesture filter, also very important new addition. Gesture are an integrated part of Windows Embedded 8. Multitouch support is an integrated part. It's not only about the user interface, but it's also being able to write application that directly tap into the new way of interacting with a computer. How do you zoom in, zoom out, flip through an application, building a kiosk, building any type of user interface? Touch is becoming more and more prominent as a request. In a specialized device, this could be a problem though. Are you want to show that you want to have the charms bar, the settings available in Windows Embedded 8 when you swipe from right to left, or the context app commands, the contextual app commands when you swipe from down to up, from bottom to up. Or maybe you just don't want to have an application that pinch and stretch or support some of those gestures. So you can filter those gestures in Windows Embedded Industry 8.1 to make sure that you provide a consistent logged on experience for your device. Next slide, please. Similarly, keyboard still there. Keyboard is an integrated part of many devices, not only a physical keyboard, but also an on-screen keyboard. And the problem with keyboard is that that is a surface of attack to access to features in the operating system that you may want to hide. Alt F4 to close the application, Control Delete to access the task manager, for example, Windows E, Windows T, the Windows key itself. So many things are so many shortcuts or functions can be accessible just for a keyboard by power user. So we have an easy way of blocking keyboard keys and combinations through the keyboard filter. We support breakout mode, and I'm going to go a little bit in details on breakout mode later for those who knows what it is. Next slide, please. So now that you block the gesture, that you have a modern app running as a shell, and that nobody can close the application or access unnecessary function through the keyboard, there's still another lockdown features that you may want to consider. It's being able to filter the writes to the mass storage, to the hard disk. Why do you want to do this? Well, there's different reasons for this. A common reason is managing the life cycle of your mass storage if there's a limited number of writes. But another common reason is to ensure that every time you boot your system, it'll boot into exactly the same state, because the writes you'll do to the hard disk will be stored in RAM and wiped out every time you reboot. That's some of the configuration and options that we can do with the unified write filter. We can filter partition, we can filter files, and we can do registry, what we call holes, so the registry is not filtered if you want to. We can configure the memory management of the write filter, making sure that it sends a system event when the RAM overlay or the RAM space that you dedicated to the write filter gets full, so you can either clean it up or commit or reboot or send a message to an administrator. So there's multiple configuration tool accessible through WMI interface, the MMC add-in that I mentioned, the Embedded Lockdown Manager. And you also have a command line tool, UWF Manager, to manage those features. All the features I'm talking about, by the way, and I should have started by this, are provided through WMI interface. So if anyone in the audience is familiar with managing WMI interface, in particular managing them through PowerShell, well, this is all possible. So it allows you very easily to create your own script that customize your image, much easier for deployment. You can even extract from the ELM those scripts to re-inject it directly. Next slide, please. So now you have a device that runs into a modern app with keyboard and gesture filtered, and the boots always in the same state with your key system files protected. There's a potential issue you may run in then. What if you want an administrator to come and access that device and access the desktop? Because everything is locked down, you may want to have still a on-site access for an administrator to go into the desktop and do whatever maintenance they have to do. So we ensure that scenario through Breakout Mode, which is, by the way, a Windows 8.1 features, not necessarily an embedded one. We just twist it a little bit so it's more usable into a specialized devices. So if you have an 8.1 device at home, or if you're running an 8.1 device today, you can, through a feature called Assign Access, assign one account to one user account that, with no administrator right, to a specific modern app. A little bit like App Launcher, but less flexible. If you do this, you'll get back to the Logon screen by pressing the Windows key 5 times. And that's Breakout Mode, the ability to press the Windows key 5 times to come back to the Logon screen. The only thing we changed on Industry is that we allow you first to disable it if you don't need it, or to change that key that you need to press. So you can select a different key and make sure that administrator come back to Logon. Of course, it only comes back to Logon. So even if you don't have the administrator password, you still cannot get into the administrator account. So now you've done that, you've got an administrator access through Breakout Mode, and you still have a potential filter you want to do. Yes, you have USB port. So if you go to the next slide, you'll see that we also have a USB filter available. USB filter is becoming more and more important. In the past, many of device manufacturers just wanted to have, either they have USB and people plug their key and everything's fine and people can transfer files, or they didn't have USB and that's also fine. Now a lot of the system need a combination of both, right? They want to have, for example, USB storage, right? But they don't want to have USB keyboards. In some cases, you don't want any USB support except a specific keyboard, manufacturer a specific keyboard that you set up. And this is now with the USB filter possible, because you can now filter devices and intercept device connection by device product ID, vendor ID, and class ID, or combination of those three. Again, accessible through WMI, and it's supported across USB 1.1, 2.0, and 3.0. You have scripts in the documentation that allows you to filter all the USB devices except the ones that are connected on the device. So fairly easy to set up and really useful in many scenarios. That's a pretty new feature as well. So next slide, please. So you filter the USB devices, you have your shell, you can get off the shell in administrator mode, gestures done. Now the system is notifying you that there is a lost network connection or some type of system events that could be very useful if you're a user writing email in an airport, but completely horrible if in that same airport your device is used to show the next flight's gates, for example. Everybody's been to an airport or any kind of public settings where they saw those pop up, where they saw dialog filters of dialog boxes happening. Of course, that is because they didn't use embedded to build their image and didn't configure the different filters we have to take off the system notification or those dialog notification. Toast notification, if you're familiar with embedded 8, are the ones that come from the right and pop up from the start menu, so you can disable them. Next slide, please. So next slide is just a list of features that the embedded lockdown manager, which we briefly talked about, can provide. It's MMC snap-in. It's fairly self-explanatory. It of course detects all the lockdown features installed in one device. One thing that I want to point out in that slide is that of course it works locally on the device, but it also works remotely. So if you have a number of devices in your LAN, in your intranet, you can control the lockdown features through the MMC snap-in remotely. Next slide, please. So that's just a picture of the embedded lockdown manager. There's no changes in terms of how it looks with the recent update we've done. There is new lockdown features that are available. I mentioned it very quickly earlier. When you set this up with a mouse keyboard with a pretty easy interface, here you see a screen that allows you to block different key combinations. You see it's fairly easy to understand how that works. You can export those settings into a PowerShell script. That way, on another machine or in an automated deployment scenario, just running that script will copy your lockdown features settings. Okay, next slide, please. I also mentioned AppLocker a little bit earlier. AppLocker is actually Windows features, and AppLocker, available for enterprise version of our product, works through group policy to ensure that only applications that are trusted, that are set up, can run on the device. It is quite a common scenario on a specialized devices that for additional security, you may want to only allow services or application that you define. Next slide, please. So that was a quick overview of our embedded features. The ability to change the shell to a modern Windows 8 Store app or to a Win32 desktop application. The ability to control how people use their devices and make sure that they don't run into a undesired state. There is a few others features that I'm not talking about for the interest of time. So if you have a specific lockdown scenario that I'd like to implement that I have not covered, please don't hesitate at the end of the presentation to ask a question. But before that, there's a couple of additional topics that I want to spend a few minutes on. The first one is application development. So we changed our application model on Windows Embedded 8.1. Well, actually, if you go to the next slide, you'll see that it's not really true. We haven't changed it. We have added another set of APIs to build touch-first application on Windows. So what we call Modern App or Windows 8 Store app is really a new set of APIs running on a different context that than desktop that we call desktop app or Win32 apps that are much better for managing touch, but also offer a set of number of device APIs to manage POS devices, scanner devices, USB devices, or connect to the cloud, being able to provide a push notification from the cloud. There's different set of API that we include in Win80 that makes sense in many, many scenarios. This doesn't mean we stop supporting desktop apps. Quite the opposite. Desktop is a key feature and it's part of the Windows future. I want to make sure that there's no miscommunication or ambiguity about that. Win32 for desktop apps, normal legacy Windows app will run on Windows 8 pretty much the same way they run on Windows 7. There's actually been there's very little forward incompatibility. Actually, there's none that I know of. I'm sure that, as an engineer, I always say, I'm never sure of myself as an engineer, but I've not seen a Windows 7 app not running on Windows 8 yet in a desktop environment. So this is basically another option to build application. Nothing has changed from the desktop app scenario. The same APIs or languages are supported. Next slide, please. So the last point I want to mention is activation. So we do have activation in Windows Made 8. And that's a point I mentioned because this causes a lot of questions about how to manage it into an embedded and specialized devices. You don't want, or maybe you don't want to connect your devices to internet to activate, as in many cases not an option. So I just want to demystify a little bit what is activation in Windows Made 8. Next slide here. So here are those slides of animations. So Che, if you can just go through the animation not too fast, and then I'll try to follow up. So online activation is really the process of gathering a identification application ID from the device, sending it to a Microsoft Activation Server with a product key, getting a confirmation ID and installing it on the device. What's interesting is that you can do it from many ways. The first one is directly through an internet connection to the device. That's how many people do it in the consumer space, for example. And this is completely transparent to the user or to yourself as an embedded OEM. Of course, as an embedded OEM, you can do it on behalf of your user. There's another one, it's called proxy activation on the next slide. Proxy activation basically allows you to use a separate tool called VMT, Volume Activation and Management Tool, to activate multiple devices in manufacturing state without those devices connected to internet directly. So they can be connected through a server, through a separate NIC, for example, or through a mass storage, say a USB key. So you're sure that even your server and any of your device have never been connected to internet. You'll still be activated. If all fail, we do have phone activation, which is the last slide. Phone activation is not a recommended way because, especially for multiple devices, that could be quite a task. That said, with online activation or different scripting method that we have for activation, PowerShell, you can script the whole activation process from server and client side through PowerShell. There is multiple way of mitigating any manufacturing scenarios issues you have, or maybe also servicing scenario you have. So this is the end of the presentation. and that was a little bit fast. I'm sorry for that, and even that I'm late as usual. So now I'd like to open it for question. I'm going to try to go back to the chat window.